And it seems like we are live and we are recording. Hey everyone, glad to have you on this session again. Feel free to engage in the chat. Let us know where you all are tuning in from. We'll be starting shortly. I myself am tuning in from New Delhi. I have Victoria with me, who is from San Diego, California. So opposite ends of the world, but here we are talking about AI and QA making an impact, learning new things every now and then. That's what the whole theme is. Learn the future of AI in testing. And with that said, let us know where you're all tuning in from. I see Irfan says, hey, from India. Here now, hello. And probably a few more. So we have Lindsay from upstate New York. Great. That's great. Let's give it a minute before other people could also join in. They might be shuffling in from the previous session, and then we could just go live. Hey, Sirpa from Sweden. Interesting.
Ooh, we cover different parts of the world.
That's something we're observing session on session. Let us know if this is the first time you're in the TestMu Conf. We've been doing it from almost more than 4 years now. So let us know if this is your first time here. How's the experience? And with that said, I think we have enough attendees on board and we can get this started. So good morning, good afternoon, and good evening to everyone from wherever part of the world you're joining in from. And welcome to another exciting session of TestMu Conf 2026. I'm Harshit Paul, Director of Product Marketing at TestMu AI, and I'll be your host for this session, where we talk about the right model for the right job, cutting LLM costs without cutting quality. Most AI agents never make it past the demo, and the ones that usually do run into the same two problems. Nobody can prove the thing that actually works, and nobody wants to explain the bill. So, how do you pick the right model for the job and cut the cost without degrading the quality? There's going to be a lot that's going to come your way around it, but before we get started, a few housekeeping items. This webinar is being recorded, so in case you need to drop off, you will get the full recording over your registered email address. We will have a dedicated Q&A at the end, so feel free to drop your questions in the Q&A box on the chat, and do share your learnings over LinkedIn and X, because we have an amazing contest going on. If you use hashtag TestMeConf, you stand a chance to win up to $1,000 prizes up to $1,000. And with that said, let's get back to the bill, because most teams are paying for capability that they never actually measured, and they have no way to actually tell what works. So for that, we have with us Viktoria Semaan, Principal Technical Evangelist and AI Engineer at Databricks. She has spent more than 15 years across cloud, engineering, and consulting. She works hands-on on multi-agent systems and RAG, and she shares her work with a community of over 630,000 tech professionals. Hey, Victoria, it's a pleasure to have you, and the stage is
Thank you
yours.
so much, Harshit. Well, really excited to tune in from sunny San Diego. It's a beautiful morning here, so keep putting the messages where you're tuning in, and we will keep an eye on the questions. So I want to make sure that the session is interactive, so feel free to put your questions, and I will try to save time at the end. That being said, we actually have a really exciting agenda, so let's dive in. So today we are going to address a really big shift in generative AI system architecture. So if you think about this, in the past 2 years, there were a lot of talk, how do we actually put LLM in production? But now, as production volume scale, organizations are encountering raising operational costs. So now we have different questions, and they are defined by token efficiency, robust evaluation, and LLM diversification. So in this session, I will discuss a framework designed to help you systematically select, evaluate, and optimize models specifically for your workload. So if we look right now at what's happening, we are living really in unprecedented times. So this chart, you can see it's from 2022 to 2026, and it basically tracks how different model providers, when they announce new models. So you can see back in 2022, 2023, the shelf life of LLM, so basically for it to stay on top, was about 12 to 18 months. But as you can see, we are moving now in 2026. This difference between those dots is just like shrinking. And right now it's about 2.5 months. So this becomes challenging because coupling your application logic directly to a single provider now introduces significant architectural risk, because those high-performing models, they keep changing. So basically, to remain competitive, your platform must be decoupled from application layer to model serving layer, and have robust evaluation and observability so that you could understand which model you need to utilize. So what we also seen, right, that there is a shift towards utilizing open weight models. The gap between this kind of like lagging gap between frontier models and open weight models right now is about 2.5 months. And what a lot of companies do, they actually fine-tune those models based on their specific task. So a good example is Cursor. I'm sure a lot of you are using Cursor. Basically, it's an IDE, and they have automated coding features. So they initially built their architecture utilizing top frontier APIs using Cloud, Sonnet, and OpenAI. But then as production volumes scaled, and they charge basically per subscription, the cost per task became basically unsustainable. So what they did, they engineered a task-specific optimization strategy, and they built a rigorous validation suite. So they analyzed their specific prompt response loops and shifted to a fine-tuned variant of open weight model 𝐸𝐚. And you can see this charted from their website. They achieved overall 86% drop on cost per task. So in this session, what I want to talk about how you can achieve similar results and what we need to do to understand how we can really get the appropriate model and reduces cost per task. So to make it a bit more concrete, I created a demo. So in this session, we are basically going to solve two problems. So let's imagine we have soccer, right? So this year was all about soccer. And our job is to moderate chat. That is where we're getting tons of messages. But if you think about moderating chat in real time, it actually involves several different tasks. One of them is just classifying messages. Is it spam? Is this some kind of obvious, let's say, ads? But then some messages might not be easy to differentiate because they may be jokes, but maybe a threat discussed as a joke. So then we have to escalate this to human reviewer. So we will be solving those two problems and trying to identify the right model for those two specific tasks. In order for us to do this, I will go through different steps that you can basically apply. First of all, just to set up kind of like what's happening right now in the industry, single model provider is already becoming structurally obsolete. We are really seeing that a lot of model providers are shifting towards open weight models. They now account for 38% of enterprise token volume globally. And the difference in price is actually quite astonishing. You can see that open weight models is about 50 cents, while frontier models is $2.41, and there is a ratio of almost 5,000x the difference between the most capable model and the cheapest model. So there's a lot also being done in those open weight models. This chart is basically shows the different countries, and you can actually see that China right now is leading the race of open weight models. So if we think about overall different models, we can characterize them by 3 different types, and each of them have a different ways you can control them. So with proprietary models, you basically pay per API, right? So you call provider and you pay per token. On Databricks, you can utilize Gateway, and we provide access to any model provider. So if you want to have Anthropic, OpenAI, or OpenWeight, 𝐬𝐤𝐿M or GLM, you can do that. With open weight models, you have a bit more choice because now you can also host the model on your own tenant. So it's not only pay per API. And with fine-tuned models, well, this is where you actually get ultimate control, because now you can fine-tune the model based on your enterprise data and then register it in Unity catalog and create a secure your own intellectual property. Besides those three general archetypes, of course, models differentiate by size, right? So we can think about Anthropic, Opus, Sonnet, and 𝐕𝐤𝐤𝐿, and there are similar variants of open weight models. So where we see frontier models really excel is for reasoning that is unmapped, and that's where you need highly complex logic, but it also introduces significant cost and latency penalties. Mid-tier, let's say like Sonnet, is great when you need a higher throughput and vast context capabilities at scale. And for low latency tasks, that's where you can use like Gemma, for example, 12 billion, and it will deliver users sub-second time to first token metrics. So it's really fast, but it's also highly specialized. So this gives you kind of like starting point to think about different choice, but of course this is not enough, and that's where we need to start building evaluation. So that's the very first step. We have to think about what our good looks like and establish this baseline. So to build the baseline, you can define this quality bar using MLflow. MLflow is the platform of choice for building high-quality AI agents and ML models. It's open source. There are over 25 million downloads a month, lots of contributors. So it started as experiment tracking for MLOps and really grew to end-to-end capability. You see that on the right, the experiment tracking, evaluation, model registry, serving, generative AI. So all of this is now part of MLflow 3 now. So how do we start? So you start with 4 steps. So step 1, you have to define your evaluation set and store it in Unity catalog. So the data examples for your use case, this might be, let's say, expected labels. So you define the questions, you define your expected labels. So let's say for our example, if we are defining for moderation, it can be like spam, harassment, all those different categories, jokes. So we have to define those labels. Then you also have to think about really kind of like edge cases where it's hard to define the exact labels. So we will create 8 categories for our specific demo. I will show you this later, how it can be done. Step 2 is you define your scores. So this can be function. Let's say you just create a Python function that will do some exact matching. This can be also built-in LLM judge. And it really depends on your use case, what score you define. Then, of course, you run it, you execute it through MLflow, and then you get traces for every single call. And finally, you can analyze the results. You will see for each model like pass, fail, accuracy, speed, cost, and this will give you a really good basis to analyze trade-off. So in our example, I ran it through 16 models. So let's see a quick demo. So Now, we first, in step 1, we define a high-quality evaluation set. So as I mentioned, here you can see 8 different categories. So those are how we're going to characterize the messages. Now we define the expected label. So if the label is correct, we said yes. If not, it's failed. And then we will run through ML evaluation. And you can see now we are running through different models and we are getting their correctness. So once we run it, we create those cases in Unity catalog. So we put some messages like what happened during conversation. And in this case, we are also defining LLM judge. So remember how I said we are doing 2 use cases. One is classification, and the second one is human escalation. So this is the human escalation. We're defining the score, how well we are defining a message for human, because we need to provide about what happened during that time, context. So we define 5 different criteria that we're going to evaluate. Whether this brief for human escalation was correct or not. And then once we run it, that's where you will see the result stored in MLflow. And you can see here accuracy, classification, macro F1. So I will then share this more on a dashboard. But every single run, so let's say if we add now a different model, will be stored in this evaluation runs in MLflow, and you can always go back and review it. So just like to summarize, basically you start MLflow by defining your scores, your judges, and you run evaluation. There are actually 2 different modes. So one is automatic, and the second is also human feedback. So somebody can also review and provide the correct response. So that's how you can get updated labels back into your evaluation infrastructure. So automatic gives you speed and scale, while human evaluation gives you ground truths on the critical examples where the model is less confident. So together, your evaluation keeps getting better and better. Now, okay, we evaluated different models, but we also need to access them. And the thing is, as I mentioned earlier, coupling your logic with a single provider is introduces like a really risk. And what you really need to think about is model-agnostic layer that will become your critical competitive differentiator. So if you build your logic in one restricted environment, then you're basically kind of like confined in this specific ecosystem. And that's where Databricks allow you to route and balance traffic across many model providers, whether it's a self-hosted or utilizing the API calls. Unity AI Gateway actually not limited to models only. You can also route to agents, MCP, external MCPs, external agents, AI coding skills, and AI coding agents. And you can also define budgets. So for, let's say, for every model, every agent, you can set your own budgets, so that, and also policies who can access them. So this gives you ability to have one, let's say, endpoint, one route, and you don't have to keep changing and hard coding those APIs in your code. So how do you actually get started? So now, okay, this is great, but it's giving you so many models. The way that we think about this, that you start first with the smallest model. You start first, you run through evaluation, and then if it doesn't pass your evaluation, that's when you can increase, right, the model intelligence and run on the same evaluation on a stronger model. you can also run them in parallel. You can actually, what I showed earlier in Unity AI Gateway, you can actually split the traffic. So let's say you've been using, I don't know, Sonnet, and now OpenAI dropped a new GPT model, and you're like, well, I just ran it on the training, but I really want to see how it's in live. You can set, for example, 10% of your traffic to go to a new release model, and then this way you get in the new traces and you're evaluating those traces. What's important, evaluation isn't really just like a one and done that you evaluated on your evaluation set. No, you keep continuously evaluating as the new models arrive, and you can get your live traces from production. Okay, now I just want to show you the dashboard. So I showed you how to run those evaluations, but here's what I got from running this evaluation. So you can see the different models. So here, open weight models are in green and proprietary are in red. And you can see Gemma 12 billion, like 12 billion products. It's a really small model. It actually performed comparable to Claude Sonnet. But if you see the price, like Gemma is so small compared to Sonnet, it's almost like feels flat, right? And at the same time, the latency is significantly increased. So we got almost similar intelligence. So let's look at this side-by-side chart. So with GPT-4 Nano, 5 Nano, we got accuracy 0.85, while the cost was $9.12. Gemma got 0.85 also on accuracy, while cost was $23. And as you can see, if we look at Sonnet, it was 0.9. Yes, it is increased, but the cost is just much, much higher. And this is where it also really decision whether it makes sense to utilize GPT-5 Nano or Sonnet. Really depends on you, because depending on the use case, you might say, well, this 0.05 actually going to cost us millions of dollars. Therefore, we are willing to pay for this model. But in our case, because it's a moderation, it's a simple classification, and it's at a very high scale, right? Because we get in so many messages to classify, it makes sense to go with a smaller open weight model. Okay, now let's talk about when do we actually need to fine-tune the model. So let's just make it clear, fine-tuning shouldn't be your default. Most of the time, the AI gateway and GRUD prompting technique will be enough. So when you actually need to fine-tune the model, when you see 3 different signals. First, your mistakes are repetitive. So the model keeps missing the same way, there is the same wrong category, the same format, the same tone, and you really want to adjust it. 2, you actually need to have labeled examples, right? You need to fine-tune them based on your data. So you need to have the data, and that's where you need to have like a few thousand of good input output pairs to start this process. And 3, you also should try really prompting and RAG before you do fine-tuning, because with fine-tuning, there's also a cost of maintaining it. So those are the trade-offs that you need to consider in terms of speed and accuracy. But we are seeing that from our customers, they are achieving really high accuracy on those fine-tuning models. If the task is narrow and you have data, this might be a way to do it. So how do you fine-tune? So in the past, it was actually quite difficult, because one of the challenge was that you need infrastructure. Now in Databricks, you can utilize AI runtime. It's basically serverless GPU. You just simply attach them to your notebook. Notebooks are already examples provided, and you select the hardware and you start fine-tuning. Once you're done, the model will be registered in Unity catalog. So here is, I want to show you results. So I actually ran the fine-tuning on open weight model. And as you can see, this yellow one is fine-tuning model classification. So with fine-tuning, the accuracy actually became 0.91. So if you remember from previous example was like 0.85, right? So now the accuracy is actually getting much closer to Opus. But again, see the difference in price, $8 versus $3,600. So that's like 40-50% difference. So fine-tuning really worked for this classification task. But at the same time, I also tried to do this for this human escalation path, and that's where fine-tuning simply didn't work. You can see out of 5, right, the scoring was from 1 to 5, it got 1.5. And why? Because as I mentioned, those kind of examples, they require complex reasoning, and that's where we see those frontier models perform better. But what was interesting for me, that Sonnet actually performed better than Opus, even so that Opus was judging it. So this again just to shows you that never go with your gut feeling, like, oh, Opus is a better model, and always establish the set. Now I know we are almost done, so I just want to give you a little preview of what's coming. So what I described is a framework. This framework is great if you have repeatable tasks. The problem is that often we are solving something new, and frankly, we don't know which model will work at the time. And what's happening now in the industry, we are moving towards smart routing, where LLMs actually are deciding based on your task, right, whether it should, which model they should direct this. So in UNTI Gateway, it's coming, there will be intelligent route requests based on the model on cost, quality, and performance objectives. So this will allow organizations to improve efficiency and reduce cost. And the goal is not simply to spend less, but it's really to maximize the value of every AI interaction. This actually is already available in Omnigent. Omnigent is open source meta harness. So you can utilize it to access different AI agents, different models, and it gives you one way to collaborate. Let's say if your friend is using Claude Code and another friend is using Codex, it's actually giving you this one layer where you can collaborate and share context. So the last demo I want to show you, I recorded this with smart routing. So let's say here, I am solving something. I just want to build a new app. I really don't know which model I need to use, but I want to make an intelligent decision. So I'm selecting Poly, a multi-intelligent agent. I selected Sonnet, and you can see first for planning, it selected Sonnet model because it classified it as moderate task. And then once it outlined to me, okay, well, this is how you can build an app. It cost me 21 cents, which is great. I can see right away. I can also set up cost budget. So since it's a simple app, let's say I want to say, I don't want to spend more than $10. And you know what? Before you actually spend $1, $5, and $7, give me a reason why you're spending and pause. Maybe I need to adjust the model. So it's going to start building now this app. And once it reaches, so it will launch several agents, it can launch agents in parallel. And then once it reaches $1, so right now it's 64 cents, it's actually going to pause and ask for my approval. So here I can see, you know, maybe I need to change a model. Maybe there's like some loops that it got stuck. So I can make decision and also assist and kind of like interrupt the smart routing process if I want to. But in this case, it was built. And then what I've also done, I said, okay, well, this is great, but now let's evaluate this. And for evaluation, I utilized a skill, and it's called investigate, so /investigate. And this skill is actually quite complex because it's asking to investigate what's being built, audit on debugging, search, and I see. So you can see then what the smart routing understood, that this is a complex task, and it routed automatically to Opus 4.5. So that's already available. It's open source. You can just go to GitHub, try it yourself. It's also available as a managed version on Databricks. So with this, just final key takeaways. Always think about evaluating models, build evaluation set, utilize Unity AI Gateway to access latest models from any model provider, fine-tune models when it really makes sense, when you have those different signals that I discussed. And here are a few resources for you to get started. And now I think we have a couple minutes for questions.
Yeah, I think we just ran out of those minutes, but let's take a couple questions because that was such a great session. Thank you so much, Viktoria, for that great walkthrough, right? So let's head to the Q&A. Quick 3 wins for somebody, for a team that's just starting the first LLM build.
Sorry, what was the question?
For a team staring at a shocking first LLM build, what are some top quick 3 wins that you would recommend?
Shocking. Oh, first. Oh, yeah. Okay, so here's what I recommend you. First, power this all through AI Gateway. If you have Cloud Code, if you have Replit, if you have all of this, just power this through AI Gateway. Set your limits and have one single place where you can control it all, because otherwise you're going to be scattered everywhere, and getting those different bills from everywhere is going to be a nightmare to manage. So just utilize Gateway as your control plane.
Great, and I think we talked a lot about this in this session as well, but what saved more? Is it switching models or caching or prompt trimming?
So models, of course, are going to help you too, because you saw there's a striking difference in price, right, between frontier LLMs and open weight models. So definitely start with models, but then that's where after the models we are going to different frameworks, right? We're going to prompting, RAG, and finally, also I will be sharing more about this, is memory, because with memory you are also caching the results. So if your questions are similar, right, you don't have to ask LLM all the time. So if you're building AI agents, look at how you can create long-term memory and short-term memory to really help you to reduce the cost and improve quality.
And that's going to be a wrap for this session. Thank you so much, Viktoria. That was a great
This was
insight.
a lot. It was supposed to be 40 minutes, so I just had to blaze it.
You nailed it. I'm pretty sure everybody agrees. I'm pretty sure, especially the comparison charts that you drew at the end, everything was brilliantly walked through. And thank you so much for everyone who has joined us in. We have more sessions lined up, so by all means, feel free to stroll past them. Happy testing and happy learning. Bye-bye.
Thank you. Bye-bye.